I assume you squared both sides first. Radicals by itself, so that's fine. Square the left-hand side, square the right-hand side. Highly suggest you copy this one out twice. And this is probably the worst part because you have to copy the big expression twice with a lot of little pieces in it. And then the other side just pops out. Square and the square would go poof. What do I do with the left-hand side?
Multiply the right-hand side.
Well, FOIL. Yeah. But it's not multiplying the inside, it's distributive property. So 2 square roots of x times 2 square roots of x.
4x.
4x. 2 square roots of x times negative square root of x minus 5.
Well, the thing, you have 2 radical
Well,
x.
negative 2 radical x.
X minus 5.
And if you want, you could put it all under one radical or separated it. It doesn't matter, but I think most people would lean towards that. You're going to get the same thing here, right? So this actually becomes 4. And then these two, when you run them into each other, negative times a negative is a positive, and then you get x minus 5 is equal to 2x minus 2. All right, now what? Combine like terms. 4x plus 1x is 5x. So what I'm going to do is cheat and say minus 5x plus 5, right? So minus 5x plus 5. Get everything onto the other side of the equation except for the radical. Okay. So that leaves me negative 4 square root of that mess. Negative 4 square root of, you could write it as x squared minus 5x if you want. That doesn't matter. Eventually you're going to have to. And then all these pieces are moved to the other side, so this equals negative 3x plus 3. That's horrid. Well, because if I divide by 4, things get messy. If you want, you can multiply through by negative 1, but it really doesn't affect anything because you're going to square it and it's going to go away anyways. So square both sides. And that'll give you 16 times the quantity x squared minus 5x is equal to, I'm going to just do this in my head, negative 3x times negative 3x.
Negative
9x squared. Negative 3 times positive 3 is negative 9. We're going to get 2 of them. So that'll be negative 18x. And then positive 3 times positive 3, of course, is positive 9. So you get that long, ugly expression. Distribute the 16. 16x squared minus 80. And then this is 9x squared minus 18x plus 9. Now what should you do?
Combine like terms. I mean, we get everything on one side of the problem.
Which side do you want to move them to? Do you want to move everything from the right to the left, or you want to move everything from the left to the right?
Right to the left, keep it positive.
Keep that x squared positive. So subtract all this mess over. This one. So subtract 9x squared, add 18x, minus 9. Some people are having problems with their signs.
I was.
Were you? I thought you were. This would be negative 9x squared plus 18x, and then the minus 9 is just going to get attached over there. Yeah, someone yesterday was, they saw a positive 9 here, and they put a minus 9 here, but they put a plus 9 over there, and I was like, ah. Hey, sleepyhead. Yeah. So let's see, this is 7x squared minus 62 minus 9 is equal to big fat 0. What's 7 times 9? 63. Oh, that's an easy one then. So this is 7x squared minus 63x plus 1x minus 9 is equal to 0. Right? Factors of 63 that x. Subtract up to a 62. All right, so here we can factor out a 7 and x. Left behind is x minus 9. Over here we can factor out a positive 1. Left behind is x minus 9, and this is equal to 0. And after you're done factoring, you get x minus 9 times 7x plus 1 is equal to 0. So x is equal to 9, or x is equal to negative 1/7. Which one can't work? Without even thinking about it too much. Zero's fine. Why not negative 1/7?
Oh, it's negative.
It's irrelevant that it's negative.
Just say it.
It's irrelevant that it is negative as an answer, but when you plug it back in here, what's it create? Well,
Negative.
2 positive 2 times a negative 1/7 is negative 2/7 minus 2 is another negative number, and you're taking the square root of a,
Negative number.
and you can't do that. It also happens over here. Negative 1/7 minus 5 is still negative. It's not because it's a negative number. It's because when you plug it in, it creates a square root of a negative number. So this is what's called a, oh, I never told you what it was called, erroneous solution. But it's one that doesn't work. The 9 more than likely works, but I'm going to check it anyways. Square root of 9, of course, is 3. 3 times 2 is 6. 9 minus 5 is 4. Square root of 4 is 2. 2 times 9 is 18 minus 2 is 16. Square root of 16 is 4. And is 6 minus 2 equal to 4? Yeah. So x equals 9 is your answer. Da, 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 da. All right. So that's radicals. The nice thing about them is the technique is the same no matter what they look like. Isolate a square root, square both sides, simplify, isolate a square root, square both sides, and then eventually solve. So today's lesson is actually nicer, kinder, easier for some people, and extremely important for people that are really going to go a little bit further with their math. This is 7-6? Yeah, 7-6. So 7-6, complex numbers. This is where we can actually take the square root of negative numbers. Of course, the answer to it is not going to be real. So let's start off with, what's the square root of 4?
2.
2. What's the square root of 9?
3.
Only because 3 times 3 is equal to 9 and 2 times 2 is equal to 4. Remember, it has to have that double factors. So if I come up to, well, let's do square root of 1. I love asking this one. Square root of 1. 1. 1 times 1 is 1. So if I have the square root of negative 1, the problem is there are no two numbers that are exactly the same that multiply together to give you negative 1. Because if they're the same, they're going to have the same sign, and if they have the same sign, the answer is always going to be positive. But the problem is this. In certain fields, you have to work with numbers that are not real. In this case, the square root of negative 1. Electronics is one of them. Physics is another. Differential equations is another. There's a lot of little places where you actually have to work with imaginary parts to get real answers, which is a little weird. So what we're going to do is, since we have to work with this symbol over and over again, instead of writing square root of negative 1, people get lazy, and they just call it I. Which is just considered the imaginary number. It is not a real number. Okay, so we're going to define the square root of a negative number. Specifically, square root of negative 1 is equal to I. So, for example, if I'm dealing with something like the square root of negative 4.
Equals I.
No.
Wow.
You need to kind of play around with it a little bit. We can use that rule where, the square root of AB is equal to the square root of A times the square root of B. Of course, the assumption there was A and B were both positive. So we can use this rule literally in only one direction. And that's the direction that I have it written. So if A and B, one of them is negative, you have to go in this direction only. It does not work in the reverse order. It's a little something interesting about imaginary numbers. It only works in this order. So when I separate it, I'm going to separate it as the square root of negative 1 times 4. Get that negative away from the 4 itself. And then I'm going to split apart the radical into two pieces. One piece is going to be the square root of negative 1. The other piece is going to be the square root of 4. And I know the answer to both of these, so all I have to do is write the answer. Square root of 4 is 2. The square root of negative 1 is I. So when I say, what's the square root of negative 4, the answer is just going to be 2 times I. It's just a neat little trick. Now, the reason that you can't go backwards with that rule, where you can't combine two radicals if A and B are positive and or negative, is this reason. If I take the square root of negative 4 and I multiply it by the square root of negative 9, the problem comes if I combine them. A negative times a negative is a positive, and you get 36, and the square root of 36 is 6. But that really isn't the answer, because watch what happens. What's the square root of negative 4? 2i. What's the square root of negative 9? 3i. And 2i times 3i is? 6i squared, which is not equal to 6. It would be equal to 6 if I squared was equal to 1, but it's not. What is I squared equal to? Well, it's I times I, which is the square root of negative 1 times the square root of negative 1. Oh, we're going to have to go backwards again. Okay? What's the square root of 3 times the square root of 3? No. 3. What's the square root of 2 times the square root of 2? 2. What's the square root of negative 1 times the square root of negative 1?
I.
No.
I1.
Oh my God, look at the pattern. Square root of 3 times square root of 3 is 3. Square root of 2 times square root of 2 is 2. Square root of negative 1 times square root of negative 1 is?
Negative 1.
Negative 1. You can't change the pattern. So I squared is equal to negative 1. This is I squared, because it's I times I, which is I squared. So these two have to be equal to each other. So one little star that you need to put at the top of your paper, very important, is I squared is definitely equal to negative 1. So I squared is a real number. I squared is a real number. So when I get down here, and this is 6i squared, that's really equal to negative 6. Because I squared is negative 1. So if we multiply them together first, we lose the sign and we get an answer of just positive 6. But the real answer, the true answer, is negative 6. What if we had, for example, the square root of negative 8? Square root of negative 8. What should we do?
From the calculator.
No, calculator ain't going to help you. What can I do with the 8?
Oh, 8 times I.
No. Think of it as just square root of 8. What would you do with square root of 8?
Is it factor like 2?
Yeah. 8 factors into 2 and
3, 2, 4.
4, and another pair of 2s. How many 2s can come out? 2. Well, 1 2 can come out because I can pair them up. So a 2 is going to come out. What else is going to come out?
The negative.
As a I. It comes out as an I. So this becomes 2i square root of 2.
Who is it?
Good God.
I think they all.
Yeah, you can sit out there. Edit city to my video today. That's okay. Alright, so when you see square root of negative 8, you still break it down the same way. The negative just comes out as an I, but the radical part breaks up exactly the same way. So for instance, if you have, what's a good one? Square root of negative 18. Square root of negative 18. Just worry about the 18 first. So 18 is 2 and 9, which is 3 and 3. What comes out?
3
is a 3. But what else comes out?
I.
That I from the negative. So we're going to get 3i square roots of 2. Now be careful. I've seen people take that negative and just bring the negative out. That is totally not what you want to do. When you see an I under or a negative under a square root, it has to come out as I. All right, what about this one?
2i. Just 2i.
2i. You can take all the threes out, so it's negative. I mean, 2i.
Why are you saying 2i? Let's go back to the beginning. The square root of -1 is equal to I. This is a cube root. The cube root of -8 is equal to -2.
Oh, yeah, because it's cubed.
Ah, yes.
Yeah,
Oh. Be careful.
No, I don't.
It's an even index.
It's a
This is an odd index. You don't care if it's positive or
negative.
negative. -2 times -2 times -2 is -8.
But if it's a square, so what if it was 4?
Then it'd be
If
positive.
it would be the cube root of -4,
No.
2.
Will you have like a
Oh.
little 4?
4 and then in the index.
Yeah.
That's a
Or
little tricky.
5.
That's trickier. We're only going to go up to,
Sorry.
well, with i's, we're only going to go up to 2.
Okay.
There is i's when you get up to 4, but then it gets a little messier. Just a little bit. Okay. So be careful of the index. The cube root of -8 is not an I. It's only square roots that give you the I. Wow, this is not racing. So we have I squared is equal to I times I is equal to, oh, actually, let me start over. I want to start at the beginning. We have I is equal to the square root of -1. We have I squared is equal to literally -1. What's I cubed equal to?
1.
Well, let's find out. I cubed is the same thing as I squared times I. What's I squared equal to? -1, so this becomes -I. So we define I to be the square root of -1. We found that I squared was equal to -1. I cubed is I squared times I, but I squared is equal to -1 times I is -I. What about I to the 4th? Well, that's I squared times I squared, right? Because I squared times I squared is I to the 4th. And I squared is -1, and I squared is -1, and -1 times -1 is +1. All right. What about I to the 5th power? How can I split that one up? What powers would you want to use? Really doesn't matter. You could do cube and 2. What would be better though? I would use 4. Why would I use 4? Because it's equal to 1. So I can write this as I to the 4th times I. Well, what's I to the 4th equal to? 1. 1 times I is? 1 times I is? 1 times I is? I. 1 times X is? X. 1 times 2 is 2. Boy. It's just a symbol. Treat it like it. All right, what about I to the 6th? How would I split I to the 6th up? I highly suggest you keep that I to the 4. I to the 4th times I squared. I to the 4th is 1. I squared is -1. 1 times -1 is -1. I to the 7th.
I to the 4th.
I to the 4th.
I to the 3rd.
I to the 3rd.
-1.
Negative I. Because I to the 4th is 1, I cubed is equal to
I don't understand this.
-I. What don't you understand? Seriously. If I is equal to square root of -1, and we figured out that I squared is that times itself, which pops out of -1, then I cubed is the same thing as I squared times I. And I know what I squared is equal to. And I know what I is equal to, I, and you get -I.
So I was gonna have to remember.
There's a trick to this if you haven't seen it yet.
Everything will either be 1, -1, or I, right? Or -I.
Yes. I, -I, +1, or -1.
Yeah.
There's only 4 answers to this. I, -1, -I, 1. I, -1, -I, 1. Because I to the 8th is I to the fourth, and I to the fourth is 1, and I to the fourth is, and 1 times 1 is 1. So the pattern just keeps repeating itself. If I went I to the 9th, it would be I to the 10th would be -1, I to the 11th would be I to the 12th would be 1. So what's the important number here?
I.
4. Why? Because every time I have I to the 4th, it's always equal to +1. Any multiple of 4. So if I said I to the 20th, the answer would be 1. I to the 21st.
So it's
It would be I. It would just be I, because there would be one I left over. I to the 37th. I to the 37th. I to the 37th.
-1.
How can I write it 37 as a multiple of 4? 36, which is 9 times 4, right? So you get I to the 9 raised to the, well, backwards, 4 raised to the 9. How many are left over? 1. So I to the 4th is 1. 1 to the 9th is 1. 1 times I is I. So if you can find the multiple of 4 built into the power, you can cancel it all away, and whatever you're left with is your answer. So what's I to the 43rd?
I.
10.
Negative
It's going to be a 10. So it would be I to the 4th to the 10th. How many are left over? 3. Now the 4th one just goes away. You're left with I cubed, and I cubed is equal to -5.
It's all in the pattern.
It's all in the pattern. All right, so I to the 237th power.
Oh my God. Whatever the
Yeah, but how would you find out? How did you know that 43 had a 10 built into it? What operation is that, though, when you're thinking that way?
Math.
Nah, I know. If I say, well, how many 4s are in 43? What operation is that? It's division. So you go off to the side and you say, 4 goes into 237 how many times? Now, 5, so that would be 20, that would be 37, and that would be 59, and this would be 36, and you have a remainder of 1. But all of these 4s turn out to be 1, and the remainder is your answer. This is just I to the first power. So, I to the 237th is I. It's a neat trick. You have to practice it a few times, though. It's not super important. It's just that the book. What?
Like I said, I was the square root of -1.
It is the square root of -1, but if you get down to it, I don't want you to write square root of -1. I just want you to write I. This becomes I to the 4th raised to the 59th. That'll bring you up to 236. And then there's one I left over. I'd just rather you write I. Don't write square root of -1
Well,
because
let's
that's.
write I squared.
But I squared is equal to -1.
You might as well not do all that.
But it's not I squared. It's not I squared. Alright. But again, this is a nice pattern, but its uses are kind of low on the totem pole. The real important one is right here. The first two are the only ones that are really, really important. Knowing that the square root of -1 is equal to I, and knowing that if you have an I squared, you have to replace it with -1. The rest of them are kind of interesting, but they don't show up that often. All right.
Okay.
What don't you get? Think about it later. Think about it later.
Never.
Like I said, the only two that are important are the green boxes over there.
Oh,
Ah.
that was one right
It goes like
So, square root of -2 times the square root of -8 minus the square root of -10. So this is just trying to get you used to that idea that the square root of a negative, you can't leave it that way.
I.
You're going to replace it with a bunch of i's. So how do I replace this one with an I?
I. What?
It's just equal to I?
I squared.
I,
No, I plus I.
No.
Times I.
no.
I minus. No, it's I.
One.
Square root of -2 is the same thing as the square root of -1 times 2, which is the same thing as square root of -1 times the square root of 2. So the -1 becomes, what's left? Square root of 2. Oh, be precise.
What? What is the retest?
You be quiet about retest. You don't have time for them anymore. So, you gotta take the negative away from the number, and the negative becomes I. The number, if it doesn't break down like over here, you have to leave it under the radical. So, what's the square root of -8? We did this one already. This is 2i square roots of 2 minus.
It's only 2 and 5.
Yeah, but it's only 2 and 5, so it can't come out. So what comes out? I. What's left behind? Square roots of 10. Yay. No. Because now we have to multiply it out now.
Now we're about to distribute it.
You have to distribute. What's I square roots of 2 times 2i square roots of 2?
2i squared.
It's going to have I squared. It's going to have a 2. And square root of 2 times square root of 2 is?
I.
2.
Times
So it's
2.
4 hours.
Oh, 2, yeah.
So this is 4. Fine. I square roots of 2 times 2i square roots of 2. Let's just write it all out. And then this one times this one is going to be minus I square roots of 2 times I square roots of 10. Since you need to see all the pieces. Which is fine. I think it's just the eyes are throwing you. If this was just square root of 2 times 2 square roots of 2, you'd all be like, oh, that's 4. But right now you're not seeing it. So, 2, let's just do it piece by piece. 2 I squared times 2. It's not times 4. It's square root of 2 times square root of 2, which is
So it's 4 hours.
2. That's 4i squared. We'll get to that in a second. Minus. Over here, I squared square root of 20. Woohoo! We're getting there. I squared, of course, is
So what?
I squared.
4.
Negative. It's a negative. So this is -4 minus a negative, which makes us a plus square root of 20. That's 2 times, which is 2 times. So I can pull out a 2. So we get 2 square roots of. Notice what's missing. The i's. Because I squared is both turned into -1. Now
Why
don't.
you just bring out a -4 in the beginning instead of...
Can't. It's only -4 because we had an I times.
I know, but I'm saying like in the middle part.
Where are you going to get a -4 out of this?
That's not the middle. I'm talking
Here?
about auto before you get that -4.
Right there.
Yeah, why didn't you just put up one right there?
What about it?
Why didn't you just put -4 right there instead of right there?
Because people were getting fussy, I would have jumped right to -4 myself. But I said square root of 2 times square root of 2 is 2 times 2 is 4, and everybody went, oh! And so I had to show all the steps. But it might come in handy if you get lost to show all the steps. Oh. I don't know why people don't like this topic. It's actually simple.
How long do you know this?
I don't matter how long I've been doing this. When I first did it, I was like, oh, this is easy.
No.
Oh, you really want to get into that topic?
Yeah.
It describes electrical circuits. When you're dealing with
Well,
electricity, I know, but eventually in your life, I don't know what you'll do within your life. You might become a rocket scientist. You never know. All right, let's beat this to death some more. How about? Oh, these are silly questions. Let me just do one just to get it out of the way. 2 plus x minus 11I is equal to 19. Oops, 19. plus yi. Basically, what you're trying to do here is solve for x and solve for y. This kind of goes back to the part where if you have equality between the two sides, then their corresponding parts also have to be equal. So there's two parts to this number. There's the part that has the I, we're going to call that the imaginary part, and there's the part that doesn't have the I, we're going to call that the real part. And I'll go into a definition after this. So this side has a real part, which is 2 plus x, and it has an imaginary part, which is negative 11i. This side has a real part that is 19, and it has an imaginary part that is yi. So the real part has to equal the real part, and the imaginary part has to equal the imaginary part. It's actually a simplistic concept.
2 plus x equals 19.
That's one of them. So you get 2 plus x is equal to 19. The real part on the left is equal to the real part on the right. And
17.
negative 11i must equal yi. Well, this one's easier to solve. What's y equal to?
11.
Negative 11. Negative 11.
I thought I was equal to negative 1.
No. I squared is equal to negative
I
1.
squared.
I is just I. Leave it alone. So here we find that y is equal to negative 11. What's x equal to?
17.
17.
Hold on. I thought I was the square root of it.
It's the square root of negative 1, but it's better to replace the square root of negative 1 with I. Don't go backwards.
So what do we do now?
It's just a representation of the square root of negative 1. It's like this represents a number. Yeah, but it represents a number. 3.1428, blah, 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 goes off to infinity.
So negative I.
Negative,
11
the square root of negative 1 is equal to the letter I.
Oh, okay. I see what you're doing. You're taking both of them away.
Well, yeah, you could divide it away. Divide both sides by I. It's okay.
But I'm saying, like, let's say you got 11 I. So that's not 11 square root of 1.
It's, all right. If I have 11i, that is the same thing as 11 square root of negative 1.
So where the I go with this?
Huh?
No,
You lost me. This I?
I'm lost. Now, both of them. Where they go?
Divide by I. Divide by I. What happens to the i's?
Okay. I'm just making sure what you did.
I mean, you're trying to solve for y. To solve for y, you would
Okay.
divide by I, and they cancel. Or you can go, oh, the real part of this imaginary piece, yi, negative 11i, so y has to be. I mean, that's just one of those concepts. But this right here, never go in this direction.
Do I understand?
Never. Don't ever change I into the square root of negative 1. But constantly change square root of negative 1 into I, because it's a simpler form of it.
So are we finished?
I know.
No.
No, I'm talking about that.
Oh, yeah. You found x is equal to 17 and y is equal to negative 11. Like I said, it's simple.
That was simple.
Everything's simple. My head is red. That's that anger thing coming out of me. I have to go to my classes. Because you're all being stubborn. Stubborn. All right. So let's define a new number. Anytime I talk about numbers, y'all get upset. Fractions, oh my gosh, the world ended. And laws of exponents, and radicals, and all this weird stuff.
Is it gonna be on the test?
Now, this is on the test.
How many?
All right, complex numbers are part of the numbers we're used to. So let me build up the numbers we're used to. We're used to, the first set is the counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then outside of the counting numbers are the whole numbers. What's the only difference between the counting numbers and the whole numbers? One of them has a 0. So the whole numbers have a 0. Outside of the whole numbers is this thing called integers. What's the difference between integers and the rest of them? They have negative values. Then outside of the integers you have the rationals, which are fractions, decimals that terminate, or decimals that repeat. Those are all the possible ways of writing them. Now, if you are if you're a counting number, you're also a whole number. If you're a whole number, you're also a integer. If you're an integer, you're also a rational number. So the number 1 is a counting number, a whole number, an integer, and a rational number. Does that make sense? Okay. If you're a whole number like 0, you are not a counting number, but it is an integer and a rational number. If you're an integer like -2, you're definitely not a whole number or a counting number, but you are a rational number. So the way this is built is what's called Venn diagram style. All the counting numbers would go in here, but they're also inside of the whole. And all the whole numbers are inside of the integers, and all the integers are inside of the rational. What's left?
Imaginary.
No, before that. Irrational. So the irrational ones are funny. They don't go around the rational numbers because all of these numbers are definitely not irrational. I'm sorry, yes, definitely not irrational. So what we do is we set up a little box, and outside of this box,
Outside the universe?
outside of the rational numbers, are the set. They go by themselves, and these are the irrational numbers. Size doesn't matter here. Rational. So these are the numbers, decimals that do not terminate and do not repeat. They go on forever and ever. Pi, square root of 2, square root of 3, things like that. Now, what's really cool is this box is the complex numbers. All counting numbers are complex, all whole numbers are complex, integers are complex, rational numbers are complex, irrational numbers are complex, which makes up all the real numbers. But then there's these other numbers out here that are considered complex numbers. So complex numbers have the form of a plus b I. They have an imaginary part to them. They have an imaginary part to them. So all real numbers are complex. They just are missing I. In other words, b is equal to 0. So if you're part of the real number system, b is equal to 0. If you're part of the complex system, b is equal to 0 is some of it, but then you might have b's that aren't 0. I guess that description isn't very good. Let me go to a different possibility. If I have a complex number, this makes more sense. There is a real part and an imaginary part. Okay. So if I have a complex number like 2 plus 3i, that's a solid, exact complex number. What's the real part? 2. What's the imaginary part? Some books call it 3. Some books call it 3i. I like 3i to emphasize that it's the imaginary part. All right, what if I have -5i? That's a complex number. What's the real part? Yeah, but if there isn't any, there has to be a value there.
1.
No, because there's no 1 out here.
0.
0. So the real part is 0, because it could be written 0 minus 5i. The imaginary part is -5i. Okay. If I have a number like 7, a nice whole counting integer rational number, what's its real part? 7. What's its imaginary part? 0 I. I like it that I there, but yeah, technically you could say 0. All right, what if I have 4 plus 3i divided by 5? The complex number 4 plus 3i divided by 5. What's the real part? What is it? 4/5. What's the imaginary part? 3i over 5. I'd rather you leave the I last, so it's 3/5 I. Now, this is a proper way of writing an imaginary or a complex number. The first one, 4 plus 3i over 5, is not the proper way of writing it. It's kind of lazy man's way of writing it. Technically, you're supposed to show the real part and the imaginary part. It's supposed to look like a plus b I. All right. Oh, we got time. So let's deal with some operations. These are brand new numbers, and anytime I show you a brand new number, I have to show you how to add them, subtract them, multiply them, and divide them. So let's go real quick. Add, subtract, same thing. So if I have 4 minus 3i minus 5 plus 6i, what's the most common mistake here that you could think of? Nope. People would FOIL this out because they see the two parentheses and they start going first, out, or in, or last. Why am I not FOILing?
Minus sign.
It's a minus sign. This is not a multiplication, this is a subtraction. So multiply it out. 4 times 5? They're FOILing it. Distribute the negative 1. So this becomes 4 minus 3i. Why does this become just 4 minus 3i? It's not affected by a sign. You can think of it as you're distributing a positive 1 if you want. Over here is negative 5 minus 6i. What do you think you would do next?
Combine like terms?
Combine like terms. 4 minus 5 is negative 1. What property allows me to do that? Commutative. And negative 3i minus 6i is?
Negative 9i.
Negative 9i. What property allows me to do that? No. Commutative. It's commutative, but there's an extra little twist to it. When you add combine like terms, what two properties are you doing? What property are you using when you're combining like terms?
Distributive.
Distributive property. You're pulling the I out and you're leaving the two numbers behind to add together. All right, and there's your answer. Ta-da! So the sum or difference of two complex numbers gives you a complex number. Okay, so that's adding and subtracting. Multiplying. I want to get through all of them. So negative 3i times 4i. Start off with something simple. Negative 3i times 4i. What do you do? Well,
Negative
commute
4i.
to get the numbers next to each other. So negative 3 times positive 4 is negative 12. And then you have I times I, which is?
I squared.
I squared, but that I squared is equal to?
Negative 1.
Negative 1. And negative 1 times negative 12 is?
12.
12. Okay, easy.
That was because you're gonna do the same one.
What? I can't make these too hard. 2i times 3 plus 5i. I really can't make these hard.
So we get in the
Oh, we
lab.
don't need it.
No. You can't make these hard. Because they're always going to be formed like binomials, and you should know how to work with a binomial. What should I do here? Distribute. 2i times 3, 6i. 2i times positive 5i, it's a positive 10i squared. The only thing you have to know is
What I squared is?
end of class, right? She doesn't need to come back. I squared is negative 1. Negative 1 times 10 is negative 10. Now here's the thing. You want to write it as a plus bi. This is the form it has to end up in when you're done. And that I should be the last thing you ever write. Last thing literally that you write. So move the 10 up front. It's negative 10 plus 6. And then the last thing you write is I. So order does matter in this. You really should. Why?
Yeah.
Standard. Kind of like
So
why do you write a
everything-
polynomial x squared, x, and
Even
1?
addition and subtraction.
Uh-huh. A plus bi. How about 2 plus 3i times 4, or no. 2 minus 3i. What would you do here? FOIL, or distribute again. 2 times 2? 4. 2 times negative 3i? Negative 6i. 3i times 2? 6i. And 3i times negative 3i? Negative 9 I squared. What happens to the middle 2 in this case? What are these called? Do you remember? Begins with a C. Conjugate. Conjugate. So this becomes 4 plus 0 minus 9i squared. So 4 minus 9i squared. It's negative 9 times negative 1, which is?
Positive.
Positive 9. And 9 plus 4 is?
13.
So here's a cool one. We just multiplied together, don't you dare, a complex number times a complex number and ended up with a whole number,
Oh, no.
literally.
I was with you.
Okay.
Where you get that positive from?
This positive?
Yeah.
Because I squared is -1.
Oh, okay.
And negative
Okay,
1 times -1 is positive 1.
Alright, I got you.
You know my rule, right?
I have a meeting I have to go to. So, it was not.
She is.
Thank God it's the end of class, huh? Yeah, 2 minutes. I do want to get to something real quick.
Don't do it.
I'm doing it.
Don't do it.
This is the one part that I'm worried about. I'm not worried about any of
She can
this.
stick it right down
2
the line.
minutes.
I have 2 minutes, that's all I need.
That's it.
Because we've done it before.
Lord.
It's got to be dividing, yeah.
We're gonna take our retest.
That's all we need to do.
Jump to the retest. Division.
Get the test, give me the retest.
4 over 2i. Now,
Improper.
it's improper because I is actually a square root. Remember, it's square root of -1? And a square root cannot go in the bottom. It has the same properties as square root, so you're going to get rid of it basically the same way. So what should I multiply top and bottom by to get rid of the... I don't need the 2. It's real. I just worry about the I. So all I have to do is multiply top and bottom by I. So 4 times I, or I. 2 times I times I. So it's 2i squared, better known as -2. 4 divided by -2.
2.
4 divided by -2. -2, and then that i's hanging around. So 4 divided by 2i is the same thing as -2i. So when you're written this way with no pluses or minuses anywhere, and there's an I in the bottom, just multiply top and bottom by I.
If it's at the top, don't worry about it.
If it's at the top, don't worry about it. Like if you have 4i over 3, just write it as 4/3 I. Just write it as 4/3 I.
Give us some of them.
Yeah, aren't those nice?
Did you have like I cube or something?
No, no. See, I'm going to stay away from the I cubes and I to the fifths, because you don't usually run into them. How about 7 over 3 minus 5i?
Take time up.
Nope. I got 1 minute.
Oh, man.
But all I have to do is show you this one and this one, and you'll be fine because they're exactly the same as square roots.
The factor.
No factoring.
What would you do?
What would I do? I need to multiply the bottom by something that makes it real. If I multiply by I attaches to the 3 but goes away on the 5.
I squared.
If I multiply by I squared, it goes away for the 3, but it stays for the 5.
You gotta
Bye.
multiply by the whole thing.
Which is,
Three
it's,
minus
3
3
plus
plus
5 plus 5.
what's it called?
That's what I'm here for.
Additive inverse.
Oh, stop it. What do they call these two? Conjugate.
That's what I said.
We're going to multiply by the conjugate, which is 3
all these terms and they're not right.
plus 5i, and 3 plus 5i, and distribute. So 7 times 3?
21.
21.
That's
7 times 5i? 35i. And then in the bottom, we're going to get 9. And is that negative 25i squared? Which is?
25.
I'll write it here, though. 25i squared. Why did I not multiply the 2 middle ones together? Because they cancel. But you might want to check. This is negative 15i, and this is positive 15i. They do cancel. So I squared is?
-1.
Negative 1 times a negative is a?
Positive.
So this becomes 21 plus 35i divided by 9 plus 25.
Equals.
What's 9 plus 25? 34, so we get this. And you cannot leave it like that. That is not a complex number. That is a complex number divided by a number. So you have to split it. And to do that, you're going to use the distributive property, even though you don't see it that way. It's going to be 21 divided by 34, so 21 34ths, plus 35 divided by 34, so 35 34ths. And the last thing you write is I. Literally, it doesn't even go next to the 35. It's the last thing that you write. And that would be the answer. we have rationalized the denominator.